Hey, what's up everybody? So in this video we're going to be solving two-step equations. It's going to be quick, but we're also going to introduce inequalities, so we're going to do a quick review over inequalities as well. So let's go ahead and get started. Here we have this inequality that we need to solve for. So we have 2x plus 4 is less than or equal to 24. Now, those of y'all who already know how to solve equations, it's essentially the same thing. You have to do inverse operations. Now, if you don't know what inverse operation means, it basically means working backwards to solve for a variable. And so you want to slowly isolate everything around the variable until you get to the variable itself. And you do it by doing the opposite of what the current operation. For example, this says 2x, 2 times x plus 4 is less than or equal to 24. So I have this plus 4 that's in the same expression. So what I'm going to have to do is do the inverse of it, which is subtract 4 from both expressions. So we already know that 4 minus 4 gives us a 0 pair, which we could go ahead and circle a 0 out or cancel out. I'm going to drop down to 2x because that's what's remaining on the left side of the inequality. 24 minus 4 gives me 20. Now, since this says 2 times x, you're going to do the inverse of multiplication, which is division. So 2 divided by 2, and you divide this by 2 as well. So whatever the coefficient of x is, like right here, that is what you're going to divide by. So 2 divided by 2 actually gives us a 1. So I like to draw 1 there to show that that gives us a 1. So I'm left with 1x is less than or equal to 20 divided by 2 gives us 10. And essentially you don't need to write that x right there or that 1 right there in front of the x. So you could just write it as x is less than or equal to 10. Now here's the review part. Since we know 10 is the number we're talking about, or is the subject here, I'm going to put a solid dot here because, for one, when you're dealing with inequalities and it's a regular less than and greater than, you're going to use an open dot because that means that number is not included in your solution set. Since this has the little equal sign or the equal less than or equal to sign or greater than equal to sign, you're going to use a solid dot to show that 10 is included in this one. So for example, if I were to give you a number here, we know that 9 is less than or equal to 10. That is true. We know that 10 is less than or equal to 10. Now, 11 is not false. Less than or equal to 10. So I just gave you an example of all these numbers. Since we know that 9 is less than 10 or less than or equal to 10, we know 10 is less than or equal to 10. That means my arrow is going to be going this way. So again, inverse operations. The first step was the additive inverse. Then we're going to do the multiplicative inverse. And then finally, draw out your number line. Now, again, just so you know, this says x is less than or equal to 10. Let's go ahead and move on to the second example. Now we're going to be exploring different cases here because there's multiple things that can actually happen, and I'm going to star key things that you need to remember. So here's this next problem. Negative b minus 2 is greater than 8. Alright, so we need to first again go ahead and do our additive inverse. So we know we want to isolate the variable first. Since the variable is right here, that means we need to get rid of this negative 2 or this minus 2 by doing the opposite of it. Since it's subtracting, you're going to add 2 to both expressions. And again, Negative 2 plus 2, that zeroes out. You're going to drop down to negative b. And 8 plus 2 gives you 10. Now what's going to happen here is I'm going to rewrite this, because since it says negative b, essentially that is saying negative 1b is less than 10. And we're almost done. So at this point, you're going to do the inverse to get rid of that negative, because we need a positive 1 there. Divide by negative b, or divide by negative 1. Divide this by negative 1. Negative 1 divided by negative 1 gives you positive 1b. Now here's the special thing. I'm going to put a little star by it. When you divide by a negative, you will change the inequality to the opposite sign. So you basically flip the sign. Right now it's greater than. When you divide by a negative, it becomes a less than. So anytime you divide by a negative, change the sign. And so 10 divided by negative 1 gives you negative 10. Alright guys, so just as a reminder, anytime you divide by a negative, change the inequality. So here's your reminder. So basically a less than becomes a greater than, a less than equal to becomes a greater than or equal to, vice versa. Now here, just to translate that and write it out, this is saying b is less than negative 10. Okay, so what are examples of that? What can I substitute into b that will give us b is less than a negative 10? Well, negative 11 is less than negative 10. Negative 12 is less than negative 10. Negative 10 is not less than 10. So this is false. This is true. This is true. So since negative 10 is not less than negative 10, we know we have to use a open dot, and all my numbers are actually going to go this way for my number line to the left, because that's all the solution set that's going to make this true. All right, 2 more problems, and then you should be able to do the rest of them on your own. Determine the solution to negative 3 times the sum of p plus 1 is less than negative 18, or less than or equal to negative 18. So I'm going to go ahead and write this out. Now what's important is anytime you have parentheses and you're going to solve an equation, you always want to do the distributive property first. There's a couple other ways you could go about this one, but right now as you're starting out, you want to always simplify first. So again, simplifying this first, I'm going to take this number, multiply this, multiply that using the distributive property. That gives me negative 3p minus 3, which is less than or equal to negative 18. At this point, I'm going to go ahead and start doing my inverse operations again. So if this is the p I want to isolate, I'm going to do the inverse first of this minus 3, which is plus 3 on both sides. That gives me my 0 pair. Let me switch back to the color. That gives me negative 15. Now again, we're going to divide by the coefficient of p, which is negative 3. So we're going to divide everything by negative 3. P is greater than or equal to positive 5. Now remember, we had to flip the symbol, or flip the inequality, because we divided by a negative. Now, over here, we're going to set up our examples. P is greater than 5. P is greater than or equal to 5. P is greater than or equal to 5. Now, at this point, I'm going to go ahead and think of some numbers. Is 5 greater than or equal to 5? That is true. It is equal to. Is 6 greater than or equal to 5? That is true. Is 4 greater than or equal to 5? That is false. So I'm going to find number 5 on here. I'm going to put a solid dot because it is the one with the equal to. And since I know it's greater than, all my x's need to be greater than 5. Now we're going to do one last problem. And we're going to take it back to almost 8th grade. Again, you always want to simplify your equation first. I see a set of parentheses. I want to make those go away. I'm going to do the distributive property. So 2 times n gives me 2n. 2 times 5 gives me 10, which is equal to -2. And I want to go ahead and point out that this particular problem, number 4, is different from the other ones because the other ones were with inequalities. These were with an equal sign. So since it's with an equal sign, there's only going to be one solution. The other ones had an infinite amount of solutions because it's an inequality. So just to continue back with this problem, we're going to do the inverse because we want to isolate the n first. So we're going to do the inverse of adding 10, which is subtracting 10 from both sides. Now, I haven't done it on the inequalities, but if you want to, it's always important to keep your work straight always. So if you need to draw your line to separate the left expression from the right expression, you can. And so 10 minus 10 gives me my 0 pair. 2n is equal to -12. At this point, I'm going to divide by the coefficient of n. N is equal to -6. So now that we have our solution, we only have one solution, so basically we're done. If you ever need to check your work though, you can always take the solution that you found and substitute it back into the problem to show that it works. So for example, 2 times n plus 5 is equal to -2. I'm going to substitute -6 into n. So 2 times -6 plus 5 is equal to -2. Now -6 plus 5 gives you -1. 2 times -1 gives me -2, which is equal to -2. So that is true. That means we did it correctly. So to review your procedures, you will want to first simplify the left and right expressions. So that means distributive property combining terms. So I'll put that in parentheses. Two, you're going to add or subtract to isolate the variable using the additive inverse. 3, you're going to divide by the coefficient of x, and then you have your solution or solution set. Now, I forgot to put in here that you're going to be dividing using the math property called the multiplicative inverse. And those are basically your expressions, so your procedures, I mean. So hopefully the video was useful. Rewatch it if you need to. Thank you. You guys have a good day.